All right, guys, welcome back. Um, this is the Unit 5 practice test study guide. Let's get to it. You guys know the drill. Do the delta. All right, we're on notes. First, so we have a fair bit of notes here. We have first derivatives you need to know and derivative rules that you need to know. X to the m, derivative x to the n is just n x to the n minus 1. Sine x is cosine x. Cosine x is negative sine x. Tan x is secant squared x. Cosecant x is negative cosecant x. Cotangent x. Secant x is secant x tan x. And then cotangent x is negative cosecant squared x. Okay, so again, helpful reminder is that all the cosines are negative, the derivatives are all negative. These are going to keep reappearing, guys. They're not going anywhere. They're still going to hang around until the end. You especially need to know these if you're doing the AP test. E to the u. So we know that derivative of e to the x is e to the x, right? So the derivative of e to the u, put that here. Derivative e to the x equals e to the x. Derivative of e to the u is e to the u times du dx. Basically, it's e to whatever, this is like a chain rule, basically. It's e to whatever the power is times the derivative of that power. A to the u is a to the u times ln a times du dx. So in this case, that a to the u ln a, well, similar to the one above, the derivative of a to the x equals a to the x ln a. So derivative a to the u is derivative a to the u ln u du dx. Basically, the u just stands for like some function or some expression that's not a regular x. So these are like the simple versions, and then it's a u. This is basically just showing you chain rule on the right. Ln u. So this is, we have not covered this yet. If you're watching this on the Friday before break, we haven't gotten to ln and log yet, but I'm putting it in because I'm going to cover it on the Tuesday before the test. Derivative of ln u is 1 over u du dx. It's a pretty easy one. And then derivative of log is 1 over x ln a, sorry, 1 over u, ln a du dx. Again, I'll go over these two when we on Tuesday before the test. Chain rule, this is review. You have f of g of x is your function. The derivative of that composite function is the derivative of the outside, inside the same, times the derivative of the inside. There's no triples or quadruples on the test. I think it's just 2. There might be 1 triple, but that, by that I mean you keep repeating it for every function that goes further inside. So for example, for, I think it's the letters these are g of h of k of x, right? This one is derivative of the outside, h k of x times derivative of the middle times the derivative of the inside. So that is what we did a couple of days ago. Product rule, again, this is review. You have f of x times g of x, right? Your two functions multiply by each other. It's left d right plus right d left. So it's f of x g prime of x plus g of x f prime of x. So pretty much most of what you're seeing on this page is review, except for this is new, this is new, this is new, this is new, and then the triple chain rule, that was new. But everything else is review. Moving on. Okay, integrals and fundamental theorem of calculus. Again, mostly review here. The integral of x to the n, by the way, it should have dx's on them. I forgot about that. My bad. The integral of x to the n dx is x to the n plus 1 over n plus 1 plus c. Okay? E to the x is just e to the x plus c. And e to the x is ax over ln a plus c. Okay? Fundamental theorem of calculus, this is the integral from a to b of f of x dx. This is just the steps. We did this 2 units ago. This is a review. You first find the antiderivative, you put that from a to b, and then it's f of b minus f of a. So this is right here, this is the antiderivative, and then this is just subtraction, plug in subtract to the bottom. And this is a review, but you do need it for average value of a function. Okay, big concepts this unit. Implicit differentiation was huge this unit. I think that's maybe the key concept of the unit. And the gist of implicit differentiation, I think it's best to show it by just doing an example problem. It's where you have x squared and x's and y's throughout the equation. Let's say we have this, right? And if you were to get it alone, right? If you had like y equals, for example, y equals 3x plus 2, this over here, this is called explicit over here because you have y alone. This is implicit because they're mixed together, and you don't get y alone, you just do it across. And so on the test, when you get these problems, you're expected to do implicit differentiation. Do not do explicit. Just follow my instructions here. Okay, so differentiating across, this will become 2x plus 2y. And the rule that you learn with implicit differentiation is that where you're differentiating a variable with respect to x, but you're not differentiating x, right? So I'm doing like d dx, all of this, right? The whole thing. That becomes a 2x, but with the y, you differentiate it, but then you have to multiply it by the derivative of y prime. And then derivative of 25 is 0. And then from here, you get y prime alone on one side. So you subtract 2x from both sides here. So you get 2y y prime equals negative 2x. And then divide both sides by negative 2y. Negative 2y. Oh, so just 2a. 2y, my bad. And you're going to get y prime equals negative x over y because the 2's will cancel. That's just an example. There'll be more later on in the video. Average value of a function is just taking the fundamental theorem of calculus and then adding one more step. So if I want average value from a to b, would be integral a to b f of x dx divided by b minus a. And that's it. This is the formula you need to know. And we'll do a problem later on, but you just need to know that formula. And to do this formula, you need to know fundamental theorem of calculus because the numerator is fundamental theorem of calculus. Mean value theorem. We are going to do this on Tuesday. So just so you know, mean value theorem, this is Tuesday. Basically, all mean value theorem says is that if you have a continuous and differential function, if there is a continuous differentiable function, let's say from a to b, then there is at least one x equals c such that the derivative of the function at c is equal to f of b minus f of a over b minus a. I'll go over this in more detail on Tuesday, but in short, what the mean value theorem says is that if you've got some continuous and differentiable function on an interval, then there is a value somewhere in that interval where the derivative of some value equals the average rate of change from those 2 points. That's all it's saying. So, like, let me draw an example maybe. So let's say this is our function, like this is our a and this is our b. Okay, and you can see the average rate of change is this. Right, this is right here. This is a ROC, average rate of change. There is some, notice there is some point, like along probably right around here. See this is the secant line that's giving the average rate of change. This would be that derivative, so that instantaneous rate of change that equals the average rate of change. So these slopes are the same. Anyway, I'll go over this on Tuesday in more detail, but that's the gist of mean value theorem. Equation of a tangent line. This is just a refresher about this specific equation that you need to know. This is all over the AP test, the equation of a tangent line. It is y minus y1 equals mx minus x1. This is all over the AP test. You just need to know this formula. When you see, find the equation of the tangent line, write down this formula. And then you're identifying what is your x1, what is your y1, what is your m. That's it. Okay. Position, acceleration, velocity. Okay. So this, again, just a review. We've done this before, like equation of tangent line, but you have position, you have velocity, you have acceleration. And to move between these values, you going right, you are differentiating. So you take the derivative to get further along. And if you're going the opposite way, you take the integral. And that's really all you need to know. Okay, so if you're given acceleration and you want velocity, you have to integrate it. And if you're given position, you want velocity, you got to derive it, take the derivative. And those are the notes. So we'll be moving on to some practice. Okay, number 1, differentiate the following. So these are the first 3 here, just so you know, these first 3 are from 5.1, delta 5.1, and these 2 down here will be delta 5.5. So the bottom 2, currently, if this is Friday that you're watching it, we haven't covered log and ln. So just know that. And then the top 3, though, we have covered. Okay. So first one, 5 to the x to the third plus cosine 2x. I have my note sheet next to me. just so I can refer to it. But I know that this is a chain rule situation where we have this outside function, which is that a to the x function. And then up here, I have sort of my mid function. And then that 2x right here is my inner function. So this is a chain rule. This is a triple chain rule. We're first going to take the derivative of the outside. And with the derivative of a to the x, or a to the u that I gave here, a to the x is a to the x ln a. And this is the chain rule version. But what that means is, if I'm taking the derivative of the outside, it's just going to be 5 to the x to the third plus cosine 2x ln 5. That's the outside. Then I'll do the inside. So taking the derivative of x cubed plus cosine 2x is going to be 3x squared minus sine 2x, and then it's going to be a 2 for the derivative of 2x. So we're going to need some colors here to show you what's going on. This is the outside right here. This is the middle right here. Same thing as this. And then the little 2 here is just, that's the derivative of that 2x there. So it's the outside, the middle, the inside. E to the sine 3x, very similar. And the derivative of e to the x is e to the x. So this is just e to the sine 3x. Don't have to do anything else. We're done. Then the derivative of sine is cosine. So we'll do cosine 3x. Then the derivative of 3x is 3. So again, one more time. That is outside. Derivative of e to the x is e to the x. It's the outside here. Then sine is cosine. That's the middle. And then last, the 3 is the inside. 3x is 3. Okay? Next one. We have a product rule here. So left d right times right d left. I may want another sheet of paper for this one. Let's see. So basically you have, this is my left function here. Like this is my f of x. This is my g of x. And you're going to put them in the equation. This is from your notes. This is the product rule right here, multiplying two functions, f of x and g of x, using this rule. So we have 7x squared minus 2x to the 6th. That's my f of x times the derivative of g of x. The derivative of g of x here is going to be, that's a to the x, so it's 6 to the 7x times ln 6 times 7. So that's using that a to the x rule. That's right here. That right here. This is a to the x ln a, or it's a to the u ln u du dx. 6 to 7x times ln 6 times the derivative of the exponent. Plus right d left, so it's 6 to 7x times the derivative of this right here. We're going to be running out of space. That's another chain rule. That's going to be, I'm going to kind of write it below here. It's going to be 6 7x squared minus 2x to the 5th times the derivative of the inside, which is 14x minus 2. I'm going to rewrite this all in one line because it looks a little messy, but basically what it comes out to is 7x to the 6 minus 2x all to the 6th power times 6x to the 7, 6 to the 7x ln 6 times 7 plus 6 to the 7x times 6, 7x squared minus 2x to the 5th, 14x minus 2. This is a square right here. This is the final answer right here. And if you're confused, like how I got these values, I'm going to go ahead and label them. Right, this is f of x. This right here is g prime of x. This is the g of x. And this whole thing here is the f prime of x. Okay. Moving on, the logs. I do need separate paper for this one. So log base 4 2x to the third minus e to the x. This is using the log rule. Log base a is 1 over u ln a times the derivative. So this is going to be, I'm going to rewrite it, log base 4 2x to the third minus e to the x is going to be 1 over 2x third minus e to the x times ln 4. That's the outside. Multiplied by the derivative of the inside times 6x squared minus e to the x, because the derivative of e to the x is e to the x. So one more time, this is outside. This is the inside. Chain rule. Okay. Next one, ln cotangent squared x plus cosecant 2x. Okay. Again, I'm going to need paper for this one. So I'm going to rewrite it. We have y equals ln cotangent squared x plus cosecant 2x. Okay. So I'm taking this again. This derivative of ln is 1 over u, or 1 over x. So the outside of this is just going to be 1 over this whole thing. Cotangent squared x plus cosecant 2x. Okay. And then we'll do the derivative of the inside now. So that's the outside on the inside. So cotangent squared x is going to be negative. So it can be 2, sorry, it's chain rule. So it's 2 cotangent x times the derivative of cotangent is negative cosecant squared x. And then plus, this is all one big parentheses, plus derivative of cosecant is negative cosecant cotangent. So this is negative cosecant cotangent 2x times 2. So let me just walk you through that again. So this whole thing on the outside, this is the outside. All of this is the outside. 1 over x, basically. That's ln. Okay. Then the inside, I'm doing each of these. So I'm multiplying this whole thing, the whole outside derivative times the derivative of the inside, which is this whole thing. 2 cotangent x times negative cosecant x plus negative cosecant 2x should be right here. My bad. Should be 2x in there. 2x cotangent x times the derivative of 2. So yeah, this is a messy one. This is a whole inside here. You just need patience for these. And like the truth is, on the test, nothing is going to be quite as complex as this. If you can handle this, okay, you're going to be fine. A good one to practice this is delta 5.3. Like this is a good one to practice these. Okay, we're on to implicit differentiation. Okay, so I'm just going to go ahead and do it, and then I'll walk you through what's going on. This is negative 2y, y prime. 2 becomes 0, plus 10x minus 1 equals 0. Get y prime alone. Just move the 10x over. That's what I'm doing. So I got negative 2y, y prime equals negative 10x plus 1. The last step to get the y prime complete alone is just to divide this by negative 2y, negative 2y, cancel, cancel. So y prime equals negative 10x plus 1 over negative 2y. The negatives can stay. You could factor out the negative from the top and cancel them. This is fine. I'm going to leave it as this. Okay, moving on. Same thing here. A little bit more challenging. Take the derivative of the whole thing at 0. Xy, it's x y prime plus y. That's left. This is product rule right here. Left d right. So x y prime plus right dx. So it's like x times the derivative of y plus y times the derivative of x. Derivative of x is 1. So that's why that's not there. Equals negative 4y prime minus 8x. We're going to get all the y primes on one side. So I'm going to move this one over, plus 4y prime, and add it over here, 4y prime. And at the same time, I'm going to get rid of this y. So I'm going to do minus y here and a minus y over here. So what I then have is xy prime plus 4y prime equals negative 8x minus y. And then from here, since I've got both y primes alone, I'm going to factor it out. Y prime comes out front. X plus 4 equals negative 8x minus 7. Then divide both sides by x plus 4. Cancel, cancel. Divide by x plus 4. So this is my answer. I'm just going to rewrite it. Y prime equals negative 8x minus 7 over x plus 4. Okay, integration. Integrate 5 dx plus x squared dx. Just while I'm at it, this should have a dx. It's my bad. The integral of a dx, again, this is a formula you should know, is integral of a dx is a dx over ln a. So this is going to be 5 to the x over ln 5 plus integral of x squared, that is an x to the n situation, so x to the n plus 1 over n plus 1 is x to the third over 3 plus c. That's it. You just need to know the integral rules, which are here. Okay. Then next, definite integral, 3 to 5 e dx plus x. So first, this is fundamental theorem of calculus on the right here. First, we need our antiderivative, which is derivative of e dx is just e dx. Derivative of x is, remember that's got a little 1 right here. So that's plus x squared over 2. And it's going to be from 3 to 5. So we'll plug in a 5. We're going to get, so then we're going to do basically f of 5 minus f of 3. We get e to the 5th plus 25 over 2 minus e to the 3rd plus 9 over 2. So combining these, it's going to end up with e to the fifth minus e to the third plus, it's going to be 16 over 2, which is 8. Because we got 25 minus 9 is 16. And then divided by 2 is 8. That's the final answer there. Okay. You leave e, you just leave as e. You don't need to worry about it. And I can't combine these because the exponents are different. So I can't combine them. Okay. Okay, moving on. What is the average value of f on the interval -1 1 written in its simplest form? Okay, this is straight from delta to delta 5.4. So we have, this is average value of a function. That form right there is going to be integral -1 to 1, because that's my a and my b, right? Of 5x squared plus 1 dx all over b minus 1 minus -1. Okay, so to solve this, we got to do the top first. So integral, the antiderivative of 5x squared is going to be 5x to the third over 3 plus x. I mean, technically a plus c. I'll put it in just because. And then that's from -1 to 1. And so we'll do 1, basically 1 minus -1, which is going to be 5 over 3 plus 1 minus, put a -1 in, -5 over 3 minus 1. So what this comes out to is 5/3 minus -5/3. That's plus 5/3. So we have 10/3. And then 1 minus -1 is 2. So we have 10/3 plus 2. Putting that all together in one fraction, 2 can be written as 6/3. So this is the same as 16/3. So then back over here, we have 16/3 over 1 minus -1 is 2. 16/3 divided by 2 is 16 over 6, which would simplify to 8/3. Okay. Next one. So just to recap on that one, we have integral from a to b, -1 to 1 of the function 5x squared plus 1 over b minus a. You use fundamental theory of calculus, which is the top right corner here. You take the integral. Antiderivative is 5x cubed over 3 plus x plus c. From -1 to 1, plug in the 1, you get 5/3 plus 1. You plug in the -1, you get -5/3 minus 1. You subtract them, that turns out to 10/3 plus 2. That's 16/3. 16/3 divided by 2 is 16 over 6. That's 8/3. And this is delta 5.4. So if you want to practice this, go to here. Practice here. Find the equation of a tangent line for x equals 0, at x equals 0 for y equals x times e to the x plus 3. So this is equation of a tangent line, which in the notes I mentioned, you've got to think, whenever you see equation of a tangent line, you should be thinking this formula, which is, again, y minus y1 equals m x minus x1. So just write that down. It's a good place to get started. And I know from reading this, my x1 is that 0, but I need to find my y1. I need to find my m. Let's go ahead and find the y1. You get the y1 by plugging in 0 into this equation. So when I plug in 0 into this, well, I get 0 times 1, which is 0, and then a 3. So y1 is 3. Just to recap that, when I plug in 0 into this, I get 0 times e to the 0 which just turns out to 0, and then plus 3. And then we'll take the derivative. So we got to find y prime. And y prime is lefty right plus righty left. So its left is x, derivative of e to the x is e to the x, plus right, e to the x times derivative of that is just 1, so it's just e to the x, and then plus 0. Again, just to recap that, derivative of 3 is 0, that's gone. Derivative of x e to the x, this is a mini product rule. That's what I'm doing right here. I'm doing product rule on the far right, f of x, g of x, lefty right, righty left. Left is x, d right, derivative of e to the x is just e to the x, it stays, plus right, e to the x, d left, derivative of x is a 1. You can imagine like this is a 1 right here. So this is all we end up with. The slope, we would plug in 0 into this. So we're going to get, that's going to turn out to 0, and then e to 0 is 1. So the slope is 1. Because when I plug in 0 into this, you get 0 e to 0 plus e to 0. This turns to 0, this turns to 1. Therefore, it's 1. Okay, so my final formula is y minus 3 equals 1 x minus 0. This just simplifies to y minus 3 equals x. Okay, so that's fine. So for this one, you write the formula, you start labeling your x's and y's and your m. You get the y by plugging in the x into the equation. You get the m by taking the derivative of y and then plugging in x into that. For all values, find all values of x which satisfy the mean value theorem for f of x equals x squared plus 1 on the interval negative 1 to 3. This is delta 5.5. Okay, for this one, mean value theorem says that if this is differentiable and continuous on this interval, negative 1 through, which it is, then at some point, or multiple points, the slope of the derivative should equal the slope of the average rate of change. So again, I'll go over this in class, but the average rate of change is f of 3 minus f of negative 1 over 3 minus negative 1. That is 10 minus 2 over 4. That's 8 over 4 is 2. Okay, so that's the average rate of change. That's the average rate of change right here. I'll go over this on Tuesday. Just reminding you, we'll go over this on Tuesday. So now I need to find where does this derivative equal to? Well, the derivative of f of x is just 2x. So where does 2x equal to? The answer is at x equals 1. So x equals 1. At x equals 1, this satisfies the mean value theorem because at x equals 1, the slope is 2, and 2 is the average rate of change. So this satisfies the mean value theorem. Okay, let's finish this. So 7 and 8, I'm going to go over them. I think 8 may end up being an extra credit problem on the test because I haven't really gone over this that much recently. And 7, again, same thing, maybe extra credit, maybe not on there. But 7 is relatively pretty easy. You have a function g, differentiable function. The table gives the values of g and its derivative as selected values of x. Is there a number c in the closed interval negative 5 to negative 3 such that the derivative of g at c is negative 4? Justify your answer. So we're given that it's differentiable. I assume it's continuous based on this, but it does need to be both. This is mean. So by the way, this is mean value theorem. So conditions are needs to be continuous plus differentiable, which I assume differentiable. I would tell you that if it was continuous on the test. I assume that this is continuous. So, okay, so it meets that requirement. And we're looking at -5 to -3 right here. So I actually don't care about this over here. And what we're seeing is there some point where the derivative should equal -4? Well, over here, we look at the derivatives. Oh, I don't see -4, right? So therefore, it must not equal it. That's actually not true. What you have to do to prove this is you need to look at the average rate of change here. So we're going from 10 to 2, right? So this is 2 minus 10, right? This is basically the slope. 2 minus 10 over -3 minus -5. 2 minus 10 is -8, and -3 minus -5 is 2. So the average rate of change is -4. And what the mean value theorem says is that if it's continuous and differentiable, then there must be some c where the derivative equals that average rate of change. So the answer to this is yes, because it's continuous and differentiable, and the average rate of change is -4. There must be some x equals c. Because average rate of change is -4, I'm looking for it to equal -4. It's continuous and differentiable. There must be one. Last problem. Suppose you are driving 90 feet per second behind a 60 miles per hour. When you get the opportunity to pass and you step on the accelerator, giving your car an acceleration of a equals 4 root t, where a is feet per second. So we're in feet per second. We're going to use that 90 because we're in feet per second, and t is seconds. Okay. What's the velocity function? So this is this last piece of notes: position, velocity, acceleration. We're right now in acceleration, and we're trying to get to velocity. So to do that, integral. So I need to take the integral of this right here, which looks challenging, but you gotta, whenever you see a radical, you need to convert that to an exponent. And this is, as an exponent, it's 4t to the -1/2. So taking the integral of 4t to the -1/2 dt is so plus 1 and divide. So it's going to be 4t to the 1/2 over 1/2, which is 8t to the 1/2 plus some c. But see how I was given the c because I'm already driving at 90 feet per second, and then I was given that acceleration. Therefore, my c is 90. So this becomes, we'll call this whatever, v equals 8t 1/2 plus 90. 9 seconds later, how fast are you going? So this, you just plug in 9 to this equation. So you're going to get 8. Remember, t to the 1/2 is the square root. That's square root of 9 plus 90. That equals, that's 8 times 24 plus 90 is 114 feet per second. How far did you travel in that time? So again, back to the equation here. How far did I travel? Well, acceleration, integral gets me velocity. Velocity, integral gets me position. That's going to give me the distance. Position is distance, right? So I got to take the integral again. But this time it's going to have bounds to it. It's going to be definite because it's from 0 seconds to 9 seconds of 8 t to the 1/2 plus 90. Okay. So antiderivative of this is 8t to the 3/2 over 3/2 plus 90t all that from 0 to 9. This is going to be kind of a calculator issue here, so I'm gonna plug some stuff in the calculator. Well, the zero. Luckily, that I don't really have to worry about the zero part, right? So at this point, I'm doing f of 9 minus f of 0. I don't have to worry about the f of 0 because when I plug in 0 here, I just get 0. I just need to find this when I plug in 9. So all I'm doing in the calculator right now is plugging in 9. So I'm doing 9 to the 3 halves. 3 halves times 8 divided by 3 halves plus 9 times 90 equals 954. So this comes out to 954 feet. Okay, that's the answer to C. What was your average velocity? This is actually very easy because since I found this integral, remember average velocity, average value, average velocity. Remember, this is my velocity function. So average velocity should be integral 0 to 9, 8t 1/2 plus 90 all over 9 minus 0. So luckily, I've just found that numerator, which is 954. So it's just 954 over 9. So 954 over 9 is 106. So that was my average velocity. Okay. So again, I think I would love for those of you taking the AP test, especially, really study this problem, and really when you take the test, this is going to be extra credit, and I really want you to give it a good go and try this one. Okay, and I would love to see you to get it right. Okay, happy studying, guys. I will see you on Tuesday.